Imagine a world without rules for solving equations. That's what we're going to talk about today. Okay? You've heard about the order of operations before. Oh, hello and good day, Algebra, by the way. Order of operations. It's essentially the rules for solving an equation or evaluating an expression. And it kind of hit home why this is so important. If we have the same expression, 3 plus 4 times 7 and 3 plus 4 times 7, there's the potential for two different answers here. Someone tell me how we get 49 from 3 plus 4 times 7. Tony? I mean, like, what would you do in that equation to get 49 as an answer for that? 7 times 3 plus 4 would give us 25. Right? We don't want to rearrange anything from this, but the way it's written, how would you get an answer of 49? John? I see no parentheses. The way it's written, how would you get 49? The way it's written. Quentin?
You do. 3 plus 4 is 7.
Yes.
7 times 7 is 49.
Thank you, Quentin. Yes. You could say that this expression equals 49 because 3 plus 4 is 7, and then you multiply that by 7 to get 49. Someone else might come along and say, no. 3 plus 4 times 7 is 31. How would you get 31 from 3 plus 4 times 7? Shay?
7 times 4 is 28. 28 plus 3 is 31.
Sure. 4 times 7, 28. Then you add the 3 on there to get 31. Okay? If this equation equaled two different things, we would have a problem, right? Because if you are someone whose job it is to make precise calculations, I'm going to bring in like pharmaceuticals here. You know, if you need to give someone the correct dosage of medicine, to where an overdose or an underdose might seriously harm that person, we don't want two different answers to the same equation here. Shh. Hey, folks. We don't want two different answers here to the same equation. That could pose a problem. Okay? So the order of operations exists to tell us exactly what we should do first. Someone comes along and says, you should add first. Someone comes along and says, I want to multiply first. The order of operations says you need to do this first. Okay? So who knows what the order of operations is? Blake. The thing.
Oh, I know. I know.
Or exponent. Little number. Exponent.
Okay.
Exponent.
Who knows the whole acronym for it? Well, we'll get to the individual operations bit. What's the whole acronym? Jeffrey? PEMDAS. Oh, that's so cute. PEMDAS? Oh. No. We're in 7th grade now. No, you did? Oh, I am going to expand your minds. What's the acronym that we're really using? Kate? PERMDAS. PERMDAS. That's a good question. Good thing you showed up today. Okay. Carter, sit flat, please. This is your warning. Okay. Blake started naming some operations here, and he started with parentheses. Parentheses isn't actually an operation, but it does come first. It's a grouping symbol. Parentheses is actually what allows us to change the order of operations if we want to. Okay? So it's not an operation itself, but it's certainly an important part of it. What's the E, Lexi? Exponents. Yes. And exponents are that little number, that little raised number above a variable or any other base. Okay, an exponent. We'll get into, we've talked about what powers are already. Exponent, power, same thing. What is the R? Rectangle's not an operation. Griffin? Radical numbers? Radical part is correct, yes. The R stands for radicals, or also called roots. But it's that symbol, the square root of a number. Okay? It is a scientific fact stated by me that people who use PERMDAS have better life quality than those who use PEMDAS. I'm just saying. I'm just saying. The M, of course, multiplication followed by division, addition, and subtraction. Jeffrey, focus on your own. Okay? And the way these operations are organized, there's a method to it, right? What do we know about the operations of addition and subtraction? What do we know about the operations of addition and subtraction? They are, starts with an O, they are opposites. Okay? They are opposites. That's why they come after, and they're kind of together. They come after multiplication and division. Because what do we know about multiplication and division? They're opposites, right? If you multiply something, if you start with a number, we'll say 5, and you multiply 5 by 3 to get 15, how do you get back to 5 again? You divide by 3, right? These operations undo each other. They are opposites. So they're on a level by themselves too. Same thing with exponents and radicals. You know, if you start, we'll pick on 5 again. If you start with 5 and you square it, what do you get? No. Oh, people.
What the heck?
Quinn, calm down. 5 squared is not 5 times 2. If we wanted 5 times 2, we would write 5 times 2. We didn't. We wrote 5 squared, Carter, which is 5 times 5. So squaring 5 gets us to 25. If we wanted to get back to 5 again, we would take the root of 25. Right? So exponents and roots, they undo each other. They're opposite operations as well. And we already talked about parentheses isn't technically an operation. It doesn't have an opposite to it. It's a grouping symbol. Okay? My point is that you're really looking at different levels here. Right? Multiplication doesn't always come before division. Addition doesn't always come before subtraction. If you have something like 10 minus 3 plus 2, you wouldn't add 3 and 2 first. Okay? Because addition and subtraction are on the same level, they're opposite operations, you'd work from left to right. What would the answer to this be here? 10 minus 3 plus 2. What? Be 9. Okay? It would not be 5. Right? Addition doesn't, people sometimes get so locked into PERMDAS, that they forget that addition and subtraction, like they're kind of the same thing in that they're opposites, so they're the same thing, but they're on the same level. So if that's all you have in the equation, you'd work from left to right. 10 minus 3 plus 2 would be 9. Okay? Quinn? The roots are not division. The symbol looks very similar. The roots mean what number times itself equals, in our example here, 25. Okay? So that's what you're kind of solving for. What number times itself? The next objective we have goes into powers and roots, so we'll talk about those more specifically. I don't think there are any exponents on this page for homework. Maybe a couple. No? So, 1. Camille. Quickly, yes. Cade.
Is there a root for every number?
Yes, although most of them are irrationals. Like if I ask you for the root of 12, there's no number times itself that equals 12. It's an irrational decimal, never ends. But we'll talk about that tomorrow. Okay, save that question for tomorrow. So anyway, back to this here. Is the answer to 3 plus 4 times 7 49, or is it 31? Which one's correct? Griffin? 31. According to the order of operations, you would need to multiply first. And then 3 plus 28 would give us 31. Okay? If you wanted it to be 49, though, and I think John started to say this earlier, if we wanted that first equation to be 49, what could we do? John? And what would allow us to do that? Add parentheses. Okay? Parentheses change the order of operations. They said, no. In this case, you add first. What? Okay? So if we wanted this to be 49, add the parentheses. Now it's 7 times 7, and that would give us 49. Okay? Questions on any of this so far? How do you know what? Sorry? So you essentially look at an equation, and you start, are there any parentheses? If there are, do those first. If there aren't, then you move on. Do I have any exponents or radicals? If you do them next. If you don't, then you move on. Do I have any multiplication or division? If you do those next. If you don't, then move on. And then you end with addition or subtraction. You multiply or divide first, depending on which one you have. If you have them both, you'd work from left to right. Right. There are essentially 4 levels to the order of operations. Start with parentheses and just kind of work your way down the ladder, so to speak. And sit flat, please. Okay, thank you. Other questions? All right, let's practice. When you do this page, I do give you enough work to show give you enough space to show your work. Okay, so 12 plus 4 times 3. If you can do this mentally, I'm proud of you. That is awesome. But I didn't leave you this much space just to write your answer really big. Okay, I want you to show me what you're doing. Okay, what would we do first in 12 plus 4 times 3? Yes. Yes, so what I want you to do is I want you to underline the 4 times 3, saying this is the step that I'm doing, and then rewrite the equation with that done. Okay? So you're multiplying first there, and that gives you 12 plus 12. Now you can finish, you can still write your answer big if you want to, right? But I need to see every step that you're doing. What would come next? 3 divided by 3 minus 2. What are we doing first here, Dayton? Good. 3 divided by 3. We underline that. What is 3 divided by 3? 1. And so we write 1 minus 2 as our next step. And what do we get? Negative 1. Negative 1. Okay. Are there any you want to do together here? Any that look particularly entertaining? Jack?
6 minus 4 plus 2 to the power of 2.
Yeah.
Power of 2 divided by 3.
Great. Let's go. What are we doing first here? We're on the third one in the second row. Sophie? Parentheses first. So I'm underlining the parentheses. Okay. Now I rewrite this to be 6 minus what was in my parentheses became a 6. I'm squaring that and dividing that by 3. Okay. If it helps you to write this 6 in parentheses still, just to remind you that's where it came from, you can, you don't have to. But what am I doing next now? What am I doing next? Dayton? Well, this 6 squared divided by 3, that's 2 operations, right? Because you have an exponent and you have division. So which one of those is being done first? Am I squaring first or am I dividing first? Squaring first, right? Exponents. So 6 squared happens next. And I get 6 minus, what's 6 squared? No! You hurt my heart whenever you say that. 6 squared is 36, right? 6 times 6. And we're dividing that by 3. So did parentheses. I did my exponent. What do I do next? Camille. Divide 36 by 3, which is 12. And I've got 6 minus 12, final answer of -6. -6. Okay? Now, your calculator, again, is a wonderful tool to help you check your answer. If you plug in this exact thing into your calculator, you will get -6. Okay? On your calculator, to do a power of 2, right above the 7, I believe it is a button that looks like this. That's your power of 2. Okay? Beside the 7, depending on which calculator you have. Okay? Right around the 7. So you can check your answer with the calculator by plugging this exact thing in. You can write the whole equation. Your calculator is powerful enough to do the whole thing at once. Okay? And you can check your answer that way. A reminder, though, you will not have a calculator on the test. You will not get credit for your homework if you don't show your steps. So if you complete the homework by just putting it into a calculator and seeing what you get, it's going to be wrong on a test because you can't use one anyway. That'd be cheating, right? But I'm also not going to give you credit for your homework because you're not showing your work. So use a calculator to help you, check it, but not to do it for you. Yes? No. So if you have an exponent higher than this, I think right above the exponent button is one that looks like this, kind of like caret. That means the to the. So if you want to take like 10 to the 5th power, you type 10, press that button, and then 5. And that would take 10 to the 5th power for you. Yes, Jack?
Okay, so for this equation, it says 6 negative, but when you enter it into the calculator, right, you'll do parenthesis 4 plus 2 and then the power button, or the parenthesis and then the power button?
Your parenthesis would come first, and then you'd hit the x squared key.
Okay.
So the exponent should be outside of the parentheses, exactly the way that it's written here. Okay? Anything else? Another you'd like to do together? We'll do one more as a group. John?
7 divided by 7 plus 3 times 8.
Okay. I got to erase my other jottings here. 7 divided by 7 plus 3 times 8. What are we doing first here? Jeffrey? Okay. Can we also do 3 times 8 in the same step? Why? Why can we do that here? Same level, part of it. Jeffrey? Right, they're separated by addition. Okay? We have to divide 7 by 7 and do 3 times 8 before we add them anyway, because addition comes at the very end. Okay? So it'd be okay in this case to do them both at the same time because one doesn't affect the other. They're not connected. We have to do them both before we add anyway. So let's just do them both together. Plus, doing that gives us more. Oh, I wrote the answer. Sorry. 3 times 8 is 24. Plus, it gives us more space to write our answer big. 25. Right there. Okay? Quentin.
What do you do for that?
I will explain shortly. Tony.
Would it be 11 plus 3 divided by 11 minus 7?
Yeah.
Can we just call that one?
What would you do first?
11 minus
Anything else?
7. Plus 3.
Yeah. That one's actually very similar to the one we just did together here because the parentheses comes before division anyway. So you might as well do them both at the same time and then divide. Yeah.
So like each level from this, can you do like subtraction before division?
No.
Or addition?
If it comes, yes, you can. Yes, but it's generally the best idea to work from left to right. So are you seeing one where you've got addition and subtraction together?
Like 18 minus 4 over 2 plus 3.
Yeah, so once you square that 4, then you'd work from left to right. You would subtract first because it comes first in the equation. Okay. Quentin asked about this section down here. Says it's possible for each expression below to equal 30, but not as they are written. Add parentheses where necessary to change the order of the solving process so that each equals 30. As it's written, 5 plus 5 times 3 would be 20, right? Because we have to multiply first. 5 times 3 is is 15. Then we'd add the 5. That gives us 20. So how could we add parentheses here to change the order of operations so that it would equal 30? That's what you're going for here, Shay. Good. So add parentheses around the 5 and 5. Now, doing that first, it becomes 10 times 3, which equals 30. So for each of these 4 remaining, you're going to be adding parentheses somewhere in the expression to make it equal 30. Okay? What's that? For each of the 4 that we have left there in this section, yes. And then the very final one says, write 2 expressions, each with 4 operations from PERMDAS. Make one expression equal 25 and the other equal 100. So one expression you will write will equal 25. The other one will equal 100. Each expression needs to have 4 operations from PERMDAS, at least 4. Okay? And that doesn't mean you can add 4 times. That's only one of the operations. You're doing it 4 times, but 4 different operations from PERMDAS. Okay? You're writing the expression out. I'm actually working on a song about the order of operations. I'm not finished with it yet. I have the chorus done, though. Would you like to hear it? Do I add or divide, subtract or multiply? The order is PERMDAS. Do it first when you see there are parentheses. The order is PERMDAS. And that's all I got so far. But I feel like it could be something. Thank you. Thank you. Thank you. Would it also surprise you to learn that I was kicked out of choir in 7th grade?
Makes sense.
True story. Yeah. Stand, Carter. That's your chair is hazardous. Okay. Any questions, comments, concerns, complaints, comments, congratulations, or criticisms? Be easy on the criticisms, please. I have a fragile ego. Yes.
Congratulations.
For?
Something.
Thank you, John. Shay? Why? Because it's good to learn things.
Yay.
It's good to learn things. Yes, Cade.
When are you making like a Spotify playlist? Or like
When's your album drop?
you're making like
Yeah, I have already three singles done. Yeah, and I'm working on a 4th right now. I'm not quite sure yet. Just so we're clear, your homework, folks, your homework is to finish CO10, page 23. It is due tomorrow. Let's play the number game tomorrow. We haven't played the number game yet. Let's get your homework done. Make sure you show your work. It's part of it. Folks, you're not dismissed yet. Hold up. Sit down, Cade. Carter, you should be standing. Quinn, turn around. Make sure you show your work. If you want credit for your assignment, it is part of it. Okay? John?
What's the name of your song in the PERMDAS?
My song? The PERMDAS song? I don't really have a name yet. All right, folks, that's my math.